Hi there, my name is Dylan McDowell, and I'm here to talk to you about what you can do to improve your RoHS testing and reduce the number of inconclusive readings. It's never been more important to be effective at using your VANTA to do RoHS screening. Guidelines establishing XRF screening protocols can be found in IEC 62321. It's important to remember that XRF screening is only one part of achieving compliance, and you should work with a compliance specialist to figure out all the steps that your organization will need to take. The IEC guidelines establish action levels, at which results are compared against in order to determine risk. These action levels establish an inconclusive range, at which results indicate that you should perform further testing on your samples. Each VANTA analyzer is set up with these action level settings already pre-programmed and can be found in both the RoHS and RoHS Plus methods on your analyzer. When you have your RoHS or RoHS Plus method active on your instrument, you can access the action level settings by opening up the menu tray and selecting RoHS action levels. Here you can see the IEC limits are already in effect, and you can already see the pass-fail cutoff limits for each calibration on the instrument. Readings that fall between your pass-fail limits will register as inconclusive. This means that the reading is close enough to the regulatory limit that you're likely to perform further testing on the sample. The RoHS guidelines establish a 30% relative safety factor in determining the action levels. For example, the regulatory limit for lead is 1,000 ppm. 30% of 1,000 ppm is 300. This means in order to register as a pass, you need to read 300 ppm less than the regulatory limit. In other words, 700 ppm, which is the pass limit you see here. The same is true in the opposite direction, hence the 1,300 ppm for the fail cutoff. Any reading that falls in between those levels is going to register as inconclusive. For bromine and chromium, the RoHS regulations only restrict certain forms of those elements, such as polybromated pyphenyl and hexavalent chromium. XRF can only measure total quantities of those elements and not those specific forms. This means that samples that have sufficient quantities of those elements will always register as inconclusive, indicating that you need to perform additional types of testing in order to determine if the restricted forms are present. Inconclusive does not mean that the analyzer was unable to accurately assess the sample. It simply means that the readings as is were close enough to the regulatory limit that it recommends doing further testing. You can set your own action level settings by selecting User Defined here at the top and establishing your own custom pass-fail cutoffs. But with that in mind, there are some more steps that you can take in order to reduce the number of inconclusive test readings and ensuring that only the readings that are close to the regulatory limit are the ones that come up as inconclusive. For starters, make sure that your test settings and test times are well established for the types of material that you're testing. You can adjust your test times by opening up the menu tray and selecting Test Times. Here you will want to make sure that your test times are long enough in order to reach your target precisions. Longer test times will make sure that you get better precision. That precision is added on to the inconclusive range from your testing, so testing for at least 90 to 120 seconds per beam is recommended to reach the best possible precision. We provide an auto classification feature which automatically selects between the plastics and alloy beams. This is fine for most samples, but if you're testing an aluminum alloy sample, we recommend changing the auto classify options to force alloy instead. In addition to instrument settings, sample type and sample presentation are key factors in determining the quality of your screening. IEC guidelines recommend testing only one material at a time or testing well-homogenized mixtures of multiple materials. If you're testing a sample that has more than one material in it, for example, the circuit board, you can utilize the VANTA's camera and collimation feature to focus in on only one material component of this sample. The VANTA workstation can help make sample presentation easier and more consistent. To help me make sure that I position the sample properly, I can bring up the camera display here in the PC software. Simply click the tab to the right of the results listing here to bring up the camera image. The red circle indicates where the X-ray beam will excite the sample, so make sure your sample is aligned such that the target material is in that circle. To activate the collimator, simply click and hold the camera image until the circle shrinks. When that circle has shrunk, it means the collimation is now active. Only use the collimator when you're testing one area and you want to isolate it from its surroundings. Using collimation will reduce the number of X-ray counts you get, so you'll need to increase test times to compensate for this by as much as 2 to 3 times your uncollimated settings in order to get similar levels of precision. Finally, if you are testing very small or thin samples or components, such as these here, you may find it useful to group together batches of these samples or to test multiple stacked on top of each other in order to ensure that you're testing enough material and to minimize thickness biasing effects. These are just a couple of steps that you can take in order to improve the quality of your results. But ultimately, it'll be up to your organization in order to determine the best course of action for you to establish a reasonable testing program. Once again, we recommend speaking with your compliance specialist in order to determine how best to implement XRF screening into your compliance testing. For questions about the VANTA, please contact your local Olympus representative. Thank you for watching.